In this chapter, we're going to explore one of the most important applications in all of science, and that is energy. Energy is the currency of science. You know, when something is becoming more energetic, something else is losing energy. If anything starts to come to action, that energy was drawn from something else. This affects gravitational pulls, it affects magnetism, it affects combustion that you have in your car. I mean, the list is limitless, and it really also affects biochemistry. We won't be getting into all of that in Module 5 here, but it is essential to learn how to tie energetic changes to chemical reactions in order to understand what's happening next from a biochemical perspective and just for general good healthcare practice. So we'll take a look at that in this chapter, and I look forward to discussing. Here in Module 5, we're going to be talking about energy and equilibrium, which are very much related to chemical reactions. When we have a chemical reaction that occurs, there's almost always some sort of a change in energy. And when we talk about equilibrium, this is to say that for some reactions, we never really reach the end. It's not like it goes from point A to point B. We end up having some balance of the starting and ending materials simultaneously. This is how a lot of biological processes work, and how when there's something that changes in our biology, our bodies will come back to an equilibrium state. These are governed by this type of reaction. But before we can really get there, it's essential to understand that the nature of what causes these processes to work, the currency of our body's ability to do kind of independent seeming things, is energy. Whether this is muscle contraction, heart pumping, brain activity, or healing wounds, there's some type of energy that needs to be expended in order to get these desired processes to work. How does our body harness energy? Well, that is a huge topic of discussion, not only in this course, but moving forward. But for now, know that these actions don't come from nothing. They require energy in order to complete. And so, stepping back even further, remember that there are two general types of energy. And we can, classify further types of energy, but everything really fits in these two different types: potential energy and kinetic energy. And so let's think about this marble that's balanced on a ramp that's propped up by a book. When it's sitting at the top, it has the ability to do work. It has the ability to get motion, to roll. And that's what it will do if we let it go, right? It'll have potential energy at the top, and if we allow it to move, it'll turn into kinetic energy. And to continue forward with this analogy, the potential energy that is contained within bonds turns into other bonds that end up giving us energy back. And the principle that really guides energy from the widest perspective is that energy isn't lost, it's just changing forms. And when we look at this marble, it starts with potential energy, and then that turns into kinetic energy. When it gets to the bottom, it's moving at a certain speed. That energy it used to have is now turned into energy of motion. Finally, when we're looking at chemicals, compounds with lower potential energy tend to be favored because they're more stable. And this kind of makes sense. Something that has high potential energy has the ability to transform into a lot of compounds with lower potential energy. Stable, low energy compounds tend to like to be formed. And I recommend you pause here and think about, well, are there a few low energy compounds that we may know or that we've seen? These would be very, very common ones. Can you name a few that may be common products in chemical reactions? All right, we've seen a few of these before, right? Water, carbon dioxide, these are very common product compounds that form biochemically. They're very low energy, they're very stable. They don't like to turn into other things. They're kind of like the ground level. And so because of that, they're formed, they're safe, and that's what results when something that has energy has been used to conduct a process and left us with these. When energy is converted from bonds to useful work, often these are the products that are formed because they have, generally speaking, low potential energy.